Okay, today I'm going to talk about CSC 2017 paper 1 question 14. This is about a question of polynomial. And the technique you can use in this question is about the division algorithm. That is, the dividend will be equal to the divisor times quotient plus remainder. That is just what you learn in primary school. Okay, on the right side, this one. Okay, then you can have the dividend equal to the divisor times quotient and then plus remainder. Even in the polynomial, we have still have the same result. So now look at the question first. We have fx, okay, and the fx here is the dividend. And then when fx is divided by 2x squared plus 8x plus 4, then this is the divisor, okay. And the quotient is 3x plus 7, and the remainder is bx plus c. Therefore, we have 4 expressions, okay. So part A, how can we find A is that we have the dividend, that is 6x to the power 3, and then minus 13x squared, and then minus 46x plus 34 will be equal to the divisor, that is 2x squared plus 8x plus 4, and then times the quotient, which is 3x plus 7, and then plus bx plus c. Okay, this is the remainder. Therefore, now, how can we solve for A, B, and C? Is that for a polynomial, the two expressions are the same. Then we can come by using by comparing the coefficients. Okay, so we can have 6 cube. Okay, for the expansion, and then we also have the ax plus ax times 3x and 4 times 3x. So we have 3ax squared plus 12x. Okay, those expansion. Okay, the terms multiplied by 3x. And then 6x is the term multiplied by 7. So I can get 14x squared 7ax and then plus 28. Okay, these three terms are the expansion by 7, and then don't forget the remainder bx plus c. So by grouping the like terms, we have 6 cubed, and then 3a plus 14. This is the coefficient square, and then 12 plus 7a, and then plus b. This is the coefficient of x, and the constant term is 28 plus c. Okay, then by compare coefficient, then we can have first negative. We need to find a only. Okay, find only. So we only to compare the coefficient of x squared. That is, the negative 13 x squared will be equal to 3a plus 14 x squared. Okay, therefore, by comparing coefficients, we have negative 13 equal to 3a plus 14. So a is negative 9. Okay, and then for part B, first please read the question. It is mentioned that Gx is a quadratic polynomial. Quadratic polynomial. It means that the highest degree of highest power of Gx is 2. Okay, degree 2 polynomial. So like you see that when it's divided by 2x plus ax plus 4, then the quotient the quotient will be a constant term. Okay, because the Gx is quadratic and the divisor is also quadratic, so the quotient must be a constant term. So for part B, B1, then we can let Gx become maybe say Q, okay, times 2x squared plus ax plus 4. The However, we only have the quotient times the divisor. We also need to have the remainder bx plus c. Okay. So again, this is about the division algorithm. Okay, I mentioned that one I mentioned in the beginning. The dividend, which is gx, will be equal to divisor times quotient plus remainder. However, here the quotient is q. Okay, so and where q is the quotient. Okay, and q is just a constant. There's no x involved because the dividend is quadratic. The divisor is also quadratic. Okay, so now, however, the question I'm not going to find q. We need to prove that fx minus gx is divisible by 2x squared plus x plus 4. So how can you do is just to start from fx minus gx. Okay, and what is gx? Now from the part A, for the result part A, I have this one. Okay, this let me use another color. This one. This is gx. So this is fx. Okay, then I can have fx equal to, so I have 2x squared and then plus ax plus 4 times 3x plus 7 and then plus 3x plus 2. This is fx. Okay. However, I need to minus gx. So minus the q times 2x squared plus ax plus 4 and then plus bx plus c. Okay, don't forget we have a bracket here for gx. Okay, this is gx. Okay, so this is expression for fx minus gx. Now, although I don't have the b and c, but I can still calculate because if we find out the terms bx plus c will be cancelled. Okay, I just copy the fx and then minus q times 2x squared plus ax plus 4 and then minus bx minus c. Okay, by extension of the bracket. Then you may find out the terms bx will be cancelled, c will also cancel. Okay, and then the remaining terms are these two. And you may find out there will be a common factor 2x squared plus x plus 4. Okay, therefore I can take out the common factor, this one, and then the term remains is 3x plus 7 minus q. Okay, now again, although we don't know what is b and c and also q, but I can prove that the expression fx minus g will be equal to 2x squared plus x plus 4 and then times 3x plus 7 minus q. So you can see that I have a factor here. The factor 2x plus 4, 2x squared plus ax plus 4. Okay, so it means that the fx minus g is a factor is divisible by 2x squared plus ax plus 4. Okay, therefore we have a conclusion. Therefore, fx minus g is divisible by 2x squared plus ax plus 4. That's all. Okay, so this is B1. Okay, last one. For B2, it is also common for the DSC to you need to someone claims that all the roots of the equation, they means that you need to solve for the equation fx minus g equals 0. Okay, so how can we do is that the first one we need to solve the equation. Then how can we solve? Is just to write down our fx minus g equals 0. Okay, this is the equation in the question. Okay, so I just copy here. And the point is what is fx minus g? Fx minus g is we did before. Okay, after our calculation, you will find out fx minus g will be 2x squared plus a plus 4 and then times 3x plus 7 minus q. Okay, so this one is 0. Okay, now and don't forget we have a in part A. The a is -9. So we have 2x squared and then minus 9x plus 4 times this. Okay, and we don't know what is the quotient Q. So actually, it will the value of Q will not affect our result, our calculation. The reason is that if I have the expression this is 0, then how can we continue? Because we're projecting 2x squared minus 9x plus 4, then which just to factorize the quadratic expression. So I can have 2x plus 1 and then times x minus 4. Okay, this is by the result. And you can use the cross method or the calculator. So, okay, after factorize, okay, I have the extension x minus 1 times x minus 4. So now, so how can we solve for x? Then the key step for you to solve the equation is that I have three terms. The product of three terms equals 0. Okay, so I can have the first one, 2x minus 1 is 0. So x is negative, x is 1 over 2, or x is 4, okay? Or x is, the last one will be q minus 7 over 3, okay? By solving the linear equation, okay? Or if you are not very familiar about this one, then maybe insert one more step for you. Okay, so we have three values of x. Okay, now, although we don't know what is value of q, but you can see that the question asks someone can say all the roots. Okay, please pay attention to the word. All the roots are integers. Okay, so you see that the three roots are 1 over 2, 4, and q minus 7 over 3. Now again, although I don't know what is q, but I can know that 1 over 2, this one is not an integer. Okay, therefore the claim is not agreed. However, how can I answer is just to put down of since 1 over 2 is not an integer. Okay, therefore the claim is disagreed. Okay, this is the explanation for this question. Okay, that's all.